Um, this video is about speed, velocity, and acceleration. Now, first of all, we're going to talk about speed. What is speed? Speed, when we say you're traveling at 30 miles an hour, what does that mean? It means you're traveling a distance of 30 miles in 1 hour. In other words, speed is distance divided by time. Now, we are going to be using the SI unit, System International Unit, or the MKS system in science. That is, the distance is measured in meters, the mass is measured in kilograms, and the time is measured in seconds. So the SI unit for speed, the distance is in meters, the time is measured in seconds, so the speed will be in meters per second. Meters per second. Or, no, in everyday life, we don't measure the speed in meters per second. We usually use miles per hour or kilometers per hour. Now, the metric unit, I'm going to be using the metric units, which is kilometers per hour. We can write speed, S for the speed, is equal to distance d divided by the time t. And you can make a formula triangle. We can write the distance on top divided by S times t. So if you want to find, we know the speed is distance divided by time. So you cover the speed. If you want to find the distance, you cover the d, is S times t, speed times time. And if you want to find the time, is distance divided by speed. So the next thing we're going to talk about is velocity. Okay, what is velocity? Now, in everyday life, we don't distinguish between speed and velocity. But in science, it has a precise meaning. Velocity is a vector quantity. It has magnitude and direction. Now, when we say the speed of a car is 70 miles an hour, okay, we're not worried about in which direction the car is traveling. However, if we talk about velocity, the pilot of an aeroplane, speaking to his ground control, will say, I'm traveling at 800 kilometers per hour, north 30 degrees west. So he is giving his velocity vector as well as magnitude, which is the 800, and also the direction, which is north 30 degrees west. So velocity is the speed in a certain direction. Now, a very good example of this is if a car was traveling at 30 miles per hour, and it keeps going at 30 miles an hour, okay, and makes a turn, and it goes in the opposite direction at 30 miles per hour. Now, we say the speed is of this car is 30 miles per hour. It's 30 miles per hour here, it's 30 miles per hour everywhere. However, if we were talking about velocity, we can say that the velocity of this is 30 miles per hour towards the right. Now, when the car is going in this way, okay, it's going in the opposite direction, then the velocity becomes minus 30 miles per hour. Okay, because we've got to take the direction into account. And that's what the difference between speed and velocity is. The next thing is acceleration. Now, acceleration is how quickly the speed changes. Okay, it's the change in speed divided by time. Now, usually when they talk about sports cars, they say the sports car can accelerate from 0 to 100 miles per hour in 8 seconds or 7 seconds. Okay, it's how quickly it can change its speed. So acceleration is the change in velocity divided by time. Now change, we're going to use the word velocity because acceleration is also a vector quantity. Okay, so and it depends on the direction. Okay, so the unit of acceleration is change in velocity is measured in, the velocity is meters per second divided by, the time is in seconds. So acceleration, the unit of acceleration is meters per second, which is meters per second squared. Okay, so we say the unit of acceleration is meters per second squared. Now, we say that the change in velocity, okay, now suppose we talk about a car moving with a velocity of 10 meters per second. If it's going at 10 meters per second, and you put your foot down on the accelerator, and the velocity increases to 40 meters per second, 40 meters per second in 10 seconds. Okay, if that happens in 10 seconds, then what is the acceleration? No, acceleration is the change in speed. A equals, now the speed changes from 10 meters per second to 40 meters per second. So it'll be 40 take away 10. The speed has changed by 30 meters per second, which is 40 take away 10 divided by, the time it takes to do that is 10 seconds divided by 10. No, 40 take away 10 is 30. 30 divided by 10 is 3 meters per second square. Okay, so the acceleration is 3 meters per second square. Now, what does that mean? It means this car is changing the speed at a rate of 3 meters per second every second. So in each second, its speed will increase by 3 meters per second. Now, if we call the initial speed as u, now these are the standard symbols they use for speed and velocity. Now, the initial velocity is u, the final velocity is v, and the time is t. Remember, initially it was moving at 10 meters per second, that's u. This is the final velocity minus the initial velocity divided by the time. This gives us a formula for the acceleration. So I'm going to rub this out and write the acceleration formula up here. So we can write acceleration A is equal to v minus u divided by t. Okay, so this is the formula for the acceleration, where u stands for the initial velocity, v is equal to the final velocity, and t is equal to the time. Okay, so this is the unit for acceleration. Now, we can make an example. Now, suppose the car was traveling at 10 meters per second, u is equal to 10 meters per second. No, we already done this example, okay? And we found the acceleration is 3 meters per second squared. A is equal to 3 meters per second squared. Now we need to understand what does that mean. It means if the car started at 0, now after 1 second, its velocity is 0. Now after 1 second, it's accelerating at a rate of 3 meters per second every second. Its velocity is changing at a rate of 3 meters per second each second. So after 1 second, this is 1 second, its velocity will be 3 meters per second. After 1 more second, it'll increase by 3 more. So it'll be 6 meters per second. After 3 minutes, it'll be 9 meters per second. Okay, after 1 more second, it'll be 3. So I hope you understand what we mean by acceleration. Okay, how the velocity is changing. It's the change in velocity. Now, what happens if, let's do an example. A car decreases its speed its velocity from 10 meters per second, from 50 meters per second to 10 meters per second. In 20 seconds. Okay, what is the acceleration? What is the acceleration? What is A? Okay, A is the acceleration. So we write down the acceleration equals v minus u. No, the final velocity is 10. Is 10 meters per second minus the initial velocity. It was moving at 50 meters per second divided by the time it takes is 20 seconds. So it's 10 minus 50, which gives you minus 40 divided by 20. Well, minus 40 divided by 20 is, that gives you minus 2 meters per second squared. Now what does that mean? If the acceleration is negative, that means it's a deceleration. Okay, the car is slowing down. So if we write acceleration is minus 2 meters per second squared, is slowing down at a rate of 2 meters per second every second. Now, if we write the word deceleration. Instead of acceleration, if we write deceleration, then we can just say the deceleration is 2 meters per second squared. Now we don't need to write the negative sign. Okay, the next thing we are going to talk about is the distance time graph. This is distance against time. Now, I'm going to be using the SI units, okay, but the units can be kilometers per hour or meters per second. So, if it goes like this, if the graph goes like this, O, A, B, and C. Okay, we're going to talk about these three. Okay, the distance traveled here is, say, 40 meters. The distance is in meters and the time is in seconds. Okay, so we're going to use the SI unit, meters and seconds. So we want to know what is happening to this body that is moving in this sort of way. That means it goes from O to A, and this is 10, this is 20, this is 30, and this is 40. So from O to A, okay, how is this body moving? It's traveling a distance of 40 meters. Traveling a distance of 40 meters, and it's taking 10 seconds to do that. Okay, so we say this is 10 seconds, this is 40 meters. So that means, and because the graph is a straight line, we say that this is moving at a constant speed or constant velocity. And here we say constant velocity. Or constant speed. Now, what do we mean by constant? Constant velocity means it's traveling equal distances in equal intervals of time. Like, for example, if the distance was 5, halfway, then this will be 20. Right? Like in 5 seconds, it'll be 20. In 10 seconds is 40. It's traveling equal distances in equal intervals of time. Therefore, the speed is constant. Now, from A to B, what's happening from A to B? The car is going at, no, a lot of people say it's going at constant speed. It's not. Now, you can see what's happening from 10 to 20 seconds. That's for the next 10 seconds. The distance remains constant, okay, at 40 meters from the origin. So that means the car is standing still, okay? It's at rest. It's not traveling at all. And from B to C, now this is constant velocity. Now we can say that the velocity is distance divided by time, which is 40 divided by 10. Okay, let's work that out. Constant velocity, which is 40 divided by 10, which is 4 meters per second. So its velocity is 4 meters per second while it's traveling from O to A. Then its velocity is 0 here, it's at rest. And then from B to C, it returns back to the origin, okay, back to its starting point. No, and what's the speed of this? The velocity of this, the distance it travels is 40, and the time taken is from 20 to 40, that's 20 seconds. 20 seconds, 40 meters. So we say that, again, it's going at a constant speed because the line is a straight line. Therefore, it's moving at a constant speed. And it's constant velocity. I'm just going to write will for velocity. And this constant velocity is going to be 40 divided by 20, which is 2 meters per second. Now, velocity is given by, now you can see that distance divided by time is same as the gradient of this graph, okay? It's this vertical over the horizontal, that's the gradient of the graph. So we say from O to A, the gradient is steeper. Now, if you go from B to C, the gradient is not as steep. Therefore, the steepness of the gradient tells us the magnitude of the velocity, okay? How big the velocity is. So BC is less than, because it's got a smaller gradient. So therefore, the velocity is smaller. So this is 4 meters per second. So the gradient of this is shallow. Therefore, the velocity is less. So we need to make a note of this, that the velocity is given by the gradient of this distance time graph. Velocity equals the gradient of distance against time graph. Okay, so you need to make a note of that and remember it. Okay, the next thing we're going to talk about is I think I need to rub this out and start from the beginning because it will need more space. The next thing we're going to talk about is the velocity time graph. Now, if we plot the velocity time graph, velocity, which is in meters per second, and the time is measured in seconds. Now again, I'm going to draw a graph like this. That's roughly. This is 10 seconds, 20 seconds, 30 seconds,